glad to see that there's a significant number of Star Trek fans in the audience. That's good. That's good to know. Okay, so now that that's being recorded, I hope you've enjoyed Dr. Phlox keeping you company while Dr. Ball was not here for the moment. Okay, we do have quite a bit of information to get through. Some of the stuff in the slides, though, it is the first slide deck is kind of massive, but some of the parts, as usual, will be more focused on than others. So let me get here. Okay. So this week, we are covering more on classes and object-oriented programming, and then we're also talking about polymorphism and virtual functions in chapter 15. So, okay. And next week's project 4, you get assigned that. You have no final exam, you just have your final project. So we do have a little bit of padding, so that'll hopefully give you, as long as nothing major happens between these days, that will hopefully give you a little bit of additional time to work on some stuff. So I think that's good for that. Let me look here. Let me think this through for a second. Do classes end in May? I thought they all ended in, what's the 2nd? It's on a Monday. Okay, so I think classes actually end on a Monday. Let's double check that though, just to make sure. We will see. There'll be no meeting on that particular day, but I just figured we'd check just to make sure. What is it under? Calendar. There we go. So that's winter. Yeah, I guess May 2nd is the last day of all classes. We had our midwinter recess, and then we have summer starting like, the very next week or the very same week, pretty much. Well, close. Oh, wait, does it not? Wait a minute. Final registration, begins May 9th. Okay, so we do get about a week off between the 2 semesters. So that's nice. That's not bad. All right, I will be teaching a couple courses over the summer. We have several that are running, some more than usual. All of my classes are going to be taught online if you have any interest in those. I believe I'm teaching a Java 2 and a JavaScript and one other one that I can't think of. Maybe it's 2 Java 2s, I think is what it is. Anyway, everything's asynchronous. So if you haven't taken that course yet and you're interested, feel free. All right, are there any questions about the previous material or the project or anything else before we get started? I did receive a few relevant to software engineering. Well, I mean, besides the courses, not anything particular. Third project is due okay, you're asking April 16th, right? Yes, project 3 is due April 16th. Correct. And Bob, I'm not sure, do you mean like any special events? Not that I'm aware of, I don't think so. And probably if we did have any, I would be aware of them since I'm the department chair, but not that I know of, nothing particularly intriguing. Yeah, tons of the courses. Do you mean like the actual software engineering course? There's a section of that running. There's several courses being taught related to software engineering. Obviously the beginning Java 2, data structures, there's tons of courses running. And also there's a Python course running as well. So for those that are interested in just taking that or think they might pick up the certificate once we get to that point, probably be about, I think it's supposed to be launched next summer, but I can't remember the exact days or anything. It could be the following fall, but we did actually get all of our programs and new courses added to curriculum today. We were at curriculum committee and they were all approved. We will have also a discrete mathematics course, or it's actually called discrete structures. Usually if you put the word math on it, the math department gets upset. So discrete structures is a course that is taken at a lot of institutions, and it's required by a lot of computer science and software engineering programs. If you end up, say, going for a bachelor's degree, for example, or if you already possess a bachelor's degree, a lot of times the prerequisites to getting a master's degree, they will include a course in data structures, of course, and then also a course in discrete structures, like the one we're starting to offer in about a year. We're going to be offering that. So it's heavily math related, but it will also have programming aspects. We'll have a machine learning course coming up as well, and a bunch of other fun stuff also. So all kinds of good stuff coming down the pipe. The data science certificate, which is really good for people who already have degrees of some sort and want to maybe expand their education, or if you are working on another certificate or degree and want to add more to your resume, the data science certificate will be available fully online. So that's another good thing to note. Okay, I did get some emails related to pointers. There were a couple of people who were a little bit confused about pointers further. So actually, let me do this. I'm going to do a new project. Okay, come on now. New project, empty project, and we will call this. I'm glad to hear that. The Udemy course really helped you understand pointers. That's good. Yeah, the Udemy course that I offered at the beginning of the semester and then reposted in case anyone missed it. Hopefully y'all were able to jump on it. I give all of my, I can't call them face-to-face or in-person students, I guess. I give all of my OCC and U of M Dearborn students access to all the courses that I do for free on Udemy. So you get lifetime access to those. I think the pointer section is really good. So I would hop on that if you were having any struggles with it. Let's call this pointers help. We'll do that, create that. Now we got pointers help. I'm going to just briefly go over some stuff that I think might help right here. Okay. That's really large. Okay. Oops, not what I wanted. I sometimes get like fat fingered and type the wrong things sometimes. I almost sent one of my friends 50,000, or was it $5,000 over Venmo, so that was cool. Intended on sending him 50, so that was kind of an interesting fun time. Almost hit send. Then I realized, hey, that's a large number. All right, so new item. I'm just going to make a very simple class, just so you can see. We'll make a header file. I'll put the entire thing inside the header file. We'll call it dog.h, and we'll put the include guard. We'll put if not defined, dog_h, define dog_h, and then end if, and then class dog, not dob. That's unfortunate. Okay, class dog, and that's right. C++, we prefer that. So we'll do public. I will put a, oh, I got to do this too, don't I? Did the same thing. I know. I just noticed it. String, we'll put the dog's name and maybe a breed. We'll do that. That's kind of cool. And I won't put any setters to change the name, so this will be an immutable class. So, oops, it doesn't like that. Parentheses, and bring that guy back there. Okay. All right. So, okay, let me see here. So I'm going to put a string name, string breed, and we are going to also have a string get name, const, right? String get breed const. So there's a class. That's the class we'll need. That's all we're going to do. I'm going to, I don't need, oh, I guess I promised to put the, you know what, I'm going to just create a separate file to put the, we'll do it the right way. We'll put the implementation in the CPP file. So dog.cpp will include dog.h, and then I'm going to do dog : dog, string name, string breed. Okay, and then we're going to do dog : get breed. Oh, that one needs to return a string, right? And that one has no parameters because it doesn't need any additional information to do its job. And we'll just do this so it compiles for the moment. String dog get name. I guess I could have put that first. Doesn't really matter. Okay, so all right, so it compiles now. For the breed, I'll return the breed, obviously, and for the name, I'll return the name. Pretty simple. Inside here, we'll say this name is equal to name, and this breed is equal to breed, and that's it for that class right there. Now, over here, in order to use it, I will include dog.h, and we will create instances of the dog. So this is, let's see, how do we want to do this? Okay, we'll do this. I'll say, I'll include a vector. I'll include vector libraries so we can use those. And I'll say I want a vector of dog pointers called dog vector. Okay. And then we're going to do dog vector dot push back a new dog, and that dog will have the name Fido, and that will be a German Shepherd. I think that's right. Dog vector dot push back a new dog. This one will be named Princess, and it's of course a poodle, although I'm not sure if we should really count poodles as dogs, but we'll go with it. So her name's Princess. We're gonna do, let me see here. We'll do Fabio, and Fabio can be a pit bull. And then one more, we'll do dog vector, new dog. And this one's name will be Ricky, and it'll be a Chihuahua. Full-size poodles are terrifying. They're I think we can count those as dogs though. They're very large, so they can get by with that. So, but they kind of scare me a little bit. They're like I'd even rather have a pit bull, even though they're a little higher risk. Anyway, okay, so for here's how we would loop through it. We could do for int. We could go with this technique, and then dog vector dot size. Okay, and then what we're going to do, since we pushed dynamically, we created an instance of these dogs as we added them. That means that it's holding pointers, because that's what we also declared it to hold. If we just put dog here, it would not hold it. We have to put dog pointer, because each cell that is inside of the vector represents a pointer to a dog. Okay. And then what we're going to do in here is we're going to print out dog vector dot at I. So that returns the pointer. Once we get that, I can then access things like, get name, right? I can say, my name is, okay, and then you can say my breed is dog vector dot at get breed, and then maybe an extra new line in there so it separates all of them. Okay, so we'll build that. And then I will run this and we will see what we get here. Okay, so it starts at the beginning of the vector. It'll say, my name's Fido, I'm a German Shepherd. My name's Princess, I'm a poodle. My name's Fabio, my breed's a pit bull. My name is Ricky, I'm a Chihuahua, right? All right. Okay, so that's a little more on I almost said on poodles, on pointers. So that should help a little bit. Yeah, they're basically shaggy rats. That's basically all they are. Okay, so we're back here. This is our update on classes that we'll be looking at, a little more on classes. So if we need that, it's there. Some of this we've already talked about already, so it's not going to be too much different, but there will be some that's pretty new. Okay, so the this pointer, which we've referred to before, and it kind of behaves the same way in Java. So if you're coming from Java, you just use this and then dot instead of this arrow. So that's one of the differences, but it's an implicit parameter passed to every member function, and it points to the object calling the function. A const member function is one that does not modify the calling object. So that's why I put const at the end of the function headers. Some of them, you're basically making a contract with that function, promising it won't try to modify any of the data inside the class. If you do, it actually triggers a compiler error. This right here, already done it, so I'm not going to belabor it, but you get a parameter here, and I can use the this to make sure that we're referring to the private data rather than the parameter. If you just put num equals num, that's confusing. It's ambiguous, at least reading it, but the way the compiler is going to interpret it and the runtime is going to interpret it is that it thinks you're talking about this one. So it's going to take the value of whatever's in this local variable, essentially the parameter, and set it to itself. And that's not what we want. So we want to make sure that we tell it, hey, I want you to set the value of your field with the same name as the parameter to the value of the parameter. Okay. Yeah, const. If you put const inside the parameter list like this, the function is prevented from modifying that parameter. So in this case, even if the original declaration was a regular integer, if you pass it into a function that has that set as const, it prevents it from modifying that variable. When you put const following the parameter list, like we have on getX near the bottom here, the function is prevented from modifying the object, meaning any of the fields inside of the object, this cannot modify it. Okay, so next up is static members. This concept also carries over from Java. A static member means that there's only one instance of the variable for the entire class. It's shared by all objects of the class if it's a member variable or what we would call a field. If it's a static member function or what we would call a static method, then that means it can be used to access all static member variables and can be called before any class objects are created. So same thing with static member variable, they exist even if there are no instances of the class. So static members are stored in an area of memory that is special for static members. It's not really on the stack or the heap. It's just an area of memory that holds static data. Okay, so right here, we have to declare a static member in the class with the keyword static, which shouldn't surprise us. So int val count, for example, you've got this class called int val. This is very simple. They're just basically, they're keeping track of how many int vals there are, int values there are, and storing the value of the image. So it's nearly trivial, the class, but that's what they're doing with it. So they make the val count static. You'll notice that inside the constructor, they are incrementing the val count, right? It was initialized, the regular values are initialized to 0, and then the val count is incremented inside the constructor. And yes, static functions or static methods are owned by the class itself rather than instances of the class. But it is, if instances of the class do exist, then the static values are shared by all instances. The static definition, to actually give it a value, like to give it a initialize it to a value like 0, for example, you have to do that outside of the class. So if I have this right here, an int value count, you give it the same data type that it has here. You don't have to put static in front of it again, but you have to use scope resolution and then val count, whatever its name is, and then equals whatever value you want to initialize it as. Okay, it can be modified, it can be accessed or modified by any object in the class. Modifications by one object are visible to all the other objects. Okay, here, this would be a static member function. So that was static data. Now, what if we add static member function called get val count so that we can actually return the val count? Since the static val count is private, if we can't get the data back from that or use it in some way, then that kind of gives us a bad day. So we're actually telling it, hey, let's return the value. So they can be called independently of any class objects through just the class name. So normally, if you have a direct object that isn't going through a pointer, you could put like my int val dot and then whatever name of the method you're calling. But with these, you don't have to even have any instances of this class in order to call its static methods. So the question arises, well, wait a minute, if I don't have any object instances, so I have no names to work with, how do I actually call static methods? So the way you do it is you use the class name, the scope resolution operator, and then get val count. Okay. Because of this, the this pointer cannot be used. So if you write a static method like this one, and if I put something like this dot whatever, or this arrow whatever equals something, you can't actually do that. It'll say, I don't know what this is. And the reason is because when you say this, you're talking about a specific object. So when I say this inside of a regular method and do an arrow, like I did with the, setting the data for the dog class, like the name and the breed, it assumes that there is an associated specific object that it's setting data for. If you have a static method and all the different objects share this same method and share the same data associated with it, the question arises, if you used this, which one would it be referring to? Is it talking about object 1, object 2, object 3? Which object? There could be 100 objects and it wouldn't know which one to use. So it disallows using the keyword this instead of a static context. It can be called before any objects of the class have been created, like we demonstrated up, where did it go? Kind of like this. We'll actually see some code, I think, in a moment. Oh, maybe not. Okay. Yeah, right here. Okay. So you can actually call it like this. You use the class name : and then something like get val count. You could do this before any instances even exist. Okay. All right. Any questions so far? Okay, the next thing up are called friends, friends of a class. There are friend functions and friend classes in C++. This is a, I guess the best way to put it, it's a controversial feature that's in C++. They removed the feature when they invented the language Java and when they invented C#, and a lot of languages don't like this, okay? So because the argument is that it's actually violating encapsulation. And we talked about encapsulation is so we can do things like the class can control who has access where, and it protects its own internal data. Friends kind of violate that. So a friend function is a function that's not a member of a class, but has access to the private, protected, or whatever members of the class. A friend function can be a standalone function or a member function of another class. That's possible too. It's declared a friend of the class with the friend keyword in the function prototype. Now, you can't write code that declares itself a friend of another class, meaning you can't say, oh, I want to access that class's private data, so I'm just going to put friend on side of mine and say that I'm a friend of that class. So the friendship has to be given, not like forced. Okay, so the friend access is given by the class that is giving the friendship or offering access to its data. So it might look something like this. So here, it could be a standalone function. So maybe we have a friend function, which has this signature. So it has to have the exact signature. It has to have the same name. It has to have, these don't really matter, but it has to take the same parameters, like a reference to a class, and then or not a reference, but just an integer. And if you write a function with that same signature outside somewhere, then it will know that this is actually the friend. And then I can say something like, okay, well, this is a class, and it's going to pass itself in essentially, or pass in an instance of the class. And then what I can do is I take that and I set its X value, its internal private data, to whatever other integer they suggested. So this is a little bit of a squirrely use of it. You wouldn't usually use this in this manner, but they're just showing you can do this. Basically, if this normally, under normal circumstances, normally this would be have to be a member function, but since it's got friend in front of it, that means it is not a member function. You'll notice that we don't have a class : in front of fset. That's because it's outside the class. Okay, so a friend function could be the member of another class. So instead of being just a global function, it could be a member of another class. So if you've got a class and then other class over here, a class is basically saying, okay, well, I'm going to grant friendship to other classes fset method. And then I say, you can have access to instances of my class, and here's the data I want you to help me replace the current data with. And it can do that, right? So the other one was just more of a global situation where this was not a member of any class. And here we've got it as a member of a different class. The third possibility, so you've got friend functions that could be either global or internal, or rather global or internal to another class, or you could actually grant an entire class a friend of another class. So basically, a class right here is granting friendship to a class named FR class, and FR class is down here. So that means all of its functions can have access and modify even the private data of this other class over here. Okay. So if FR class is a friend of a class, then all member functions of FR class have unrestricted access to all members of a class, including the private members. In general, you should restrict the property of friendship to only those functions that must have access to the private members of a class. Now, there is a use case for this that is actually not, normally we want to avoid this, but the use case for it would involve operator overloading, which we've not talked about. We will at some point in the future. I believe I think we talk about it near the end of the class. Maybe we don't. I can't remember. It may be it's possible it's in the set of lectures, but operator overloading is kind of like function overloading, where you're able to redefine what a particular function does. But in this case, you can actually redefine what an operator does for different types of classes. So if I have a person class and I want to be able to quote add two people together, and maybe it generates another person, like reproduction, then it would you could modify the definition of the plus sign or addition operator to basically take two different people instances and then produce another person with similar genetic traits or something. So in general, you should restrict, again, the property of friendship to only the functions that have to have access. So class friendship is considered more dangerous. Another thing, okay, so this is 11.4, member-wise assignment. So this would assign one object to another, or it helps initialize a new object with an object's data. So examples would be, if let's assume we have a class named V, and I have two instances of this class, V1 and V2. And then let's say that I've assigned values to V1. Later on, what I could do is I could say V2 equals V1, and it will do what's called member-wise assignment. So that means, let's say it has three fields, three data members. It will assign the corresponding data members from one of the objects to the other, given that they are the same data type. Okay, so V2 equals V1. Let's say they have data A, B, and C. V2's A is going to be set to V1's A, V2's B is going to be set to V1's B, and V2's C is going to be set to V1's C. Okay, and same thing here. Instead of just assigning it at some point, you can also do initialization. The difference between initialization and any given assignment is that initialization is an assignment, but not vice versa. And initialization means that it's the first time something is receiving a value. So this would be the first time that the object V3 would be obtaining values from V2. Okay, and then that was only like one slide. So friendship is very different from inheritance. Inheritance is basically it's considered a more object-oriented way of doing things, and it allows one class to absorb certain properties and maybe even data from another class, and that data has to be either public or protected. Any of the data or the behaviors, meaning methods, that are private are not inherited. Okay, you don't have direct access to them. So friendship actually goes above and beyond what we would consider inheritance, and a lot of people, again, don't like it because they see it as breaking encapsulation. Okay, so they are different. Friendship is actually a lot more open. You can actually do more stuff rather than inheritance, which does have some restrictions, and it's a lot more organized, really. So copy constructor is the next thing. Yes, copy constructors are a new thing that we haven't covered before. So a copy constructor is a constructor. It's a special type of constructor used when a newly created object is initialized with the data of another object of the same class. So the default copy constructor, or the no argument copy constructor, the default, it would be the one generated by the compiler. The default copy constructor copies field to field using member-wise assignment. So it goes, like I said earlier, if you have the objects, it would go like object.a equals the other things A, and then object B was the other things B, and so on. The default copy constructor works fine in most cases, so we usually just leave it alone. However, problems occur when objects contain pointers to dynamic storage. So this could be potentially an issue. So let's say that we have a pointer as part of the private data of this class CP class. That pointer's name is P, okay? And it's a pointer to an integer. Tom, did you have a question?
Yeah, so about the copy constructors, I guess I'm thinking of Java. Java doesn't have a default copy constructor, right? Like every time I've seen a copy constructor in Java, like the programmer has to define.
Yeah, I don't believe that it. I don't believe it does.
Okay.
Because, well, it's a little bit different behavior with Java, because when you create a class instance, you have to use the new keyword. So actually, every time you create an instance of a class, it's dynamic. Whereas with C++, it does not necessarily have to be. So they do have some differences in behavior because of that. And one of the things here is that it does do this does member-wise assignment. So if I just say one object equals another object, you're actually copying the reference of one object to another. So if I just say, for example, if I have two references in Java, one's called, for a person, maybe it's Bob, and the other is called Randy. If I say Bob equals Randy, all that's going to do is copy over the address. So that does not do member-wise assignment. So yes, it has to be explicit in Java.
Okay, all right.
So in this case, you'll see problems can occur when objects contain pointers to dynamic storage. So you notice we have a pointer P, and then we have this method, this constructor that has, this will actually, the CP class constructor under public will actually allow us to call this with no parameters, no arguments passed in. But that's because it has a default argument. The default argument allows us to say, okay, well, this integer V that we're interested in, we're just going to set it to 0 if you don't pass any additional parameters. But if the user passes in 100, then it uses V equals 100. But if it doesn't, it'll say V equals 0. In the actual code, it says the pointer equals new int. So it creates a new integer on the heap. And then what they're doing is they're dereferencing and grabbing the value from whatever the user passes in. So they're copying that over into the box of data that the pointer points to. And then the destructor is called automatically when an instance goes out of scope, and it just deletes that. Okay, but the potential issue is that if I have this situation, this is a dumb if statement, by the way, but if I have this situation where I have C1 and I then say down here in the if statements, the class instance C2 equals C1, it's going to do a member-wise copy, so it's going to try to copy over the data. But remember that data is not just some basic integer living inside, it's a pointer that's going to point to the data. So it tries to, what happens here when I say C2 equals C1, it's actually going to copy over member-wise the different data, but that would include pointers. So that means it's trying to copy over the pointer, so it will grab the same address, and then you'll have two fields, or even more, depending on what happens, pointing to the exact same data. Okay, so if any one of them change it, it changes it for all of them, and that's not usually what we want. So that can cause some very serious issues because of the sharing of the storage. The destructor of one object deletes memory still used by other objects. Modification of memory by one object affects other memory sharing objects sharing that memory. So that would be a problem with sharing dynamic storage. Programmer defined copy constructors. So if you're going to define one, a copy constructor is one that takes a reference parameter to another object of the same class. Okay. It could also be a pointer, but the copy constructor uses the data in the object passed as a parameter to initialize the object being created. The reference parameter should be const to avoid potential data corruption. Okay. The copy constructor avoids problems caused by memory sharing. It can allocate separate memory to hold the new object's dynamic member data. So instead of just trying to point to that same data, you can make a copy. It can make the new object's pointer point to the new object's own dynamic memory rather than the old one. It copies the data, not the pointer, from the original object to the new object. Okay, so this would be a copy constructor here. Over here, top one. This one is taking a reference to any object of type CP class that is passed in. You'll notice that instead of creating a regular old integer int I or something and then saying I equals obj.p, what they're doing here is they're creating brand new memory for it and then dereferencing it so they can store a copy of the data that the other object's p variable is holding. So it's actually very, very powerful. So when is a copy constructor called? A copy constructor is called when an object is initialized from an object of the same class. An object is passed by value to a function, that has to copy it. Remember, because pass by value is basically pass by copy. That's why it's more efficient to pass, for example, a constant reference or a reference, more so than anything, a reference or a constant reference if you don't want it to be modified. An object is returned using a return statement from the function. Okay. They do. Okay. They do cover operator overloading here. Are there any questions so far? Okay. The question is, so changing a value in memory using a pointer from the copied class will change the same value of the original class. Yes, if you are, okay, if your internal data is a pointer and I'm making a copy from another object of my same class type, if I don't just copy the value over into new memory like they did here, let me see, where was it? So around 27, right here. Do you see how they create a brand new box of memory in order to hold the data, and then they dereference it and set it to V? If I were to just say, have them pass in the pointer instead, and I just say, okay, well, P equals V, and not have to worry about it. But the problem there is that you would have potentially multiple classes pointing to the same exact piece of data. Okay, so that's not what we want. So yeah. So if you copy the actual data, you're good. But if you try to copy the pointer itself, then that's going to be a problem, because remember, a pointer is a memory address. And if you have multiple, say, objects with a field in them that are pointers, and they all have the same memory address associated with them, that means they're all pointing to or staking claim on this same object. Okay. The next thing up is operator overloading. So operator overloading is very much like function overloading. I mentioned it a minute ago, but operators such as equals, plus, and minus, multiplication, division, whatever, can be redefined for use with objects of a class. The name of the function for the overloaded operator is operator. So you actually treat it as if it is a function. The syntax is very similar to a function, but you use the keyword operator and then immediately followed with no spaces by the operator that you want to overload or change the behavior of. So plus and equals are very common to do that too. Operators can be overloaded as instance member functions or as friend functions. The overloaded operator must have the same number of parameters as the standard version. For example, operator equals must have 2 parameters, since the standard equals operator takes 2. In other words, you can't, even though you can redefine the behavior for these operators, you can't change the number of operands that they take. So I couldn't just say, oh, I'm going to make this a unary operator instead of a binary operator, or make it a ternary operator. You can't do that. You can redefine what it does with the equals symbol. So here's an example: a binary operator, meaning it has 2 operands, that is overloaded as an instance member, needs only 1 parameter, which represents the operand on the right. Now, the reason that we can define it this way, we're basically saying it'll return an OP class instance, and it's the plus operator, and as a parameter it takes OP class right, because let's say I have in the actual code, maybe in main, I might have OP class A, and then maybe dot 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 whatever it does, and then I have OP class B, and then we put data in those, and then later on I might have an OP class C equals A plus B. So this has to have some sort of definition as to what does it actually mean. And the plus operator sits here, and then when you see the parameter, it's referring to the thing on the right. Okay, so whatever's right of this operator, the operand to the right is passed in as this right here. Now, what about the left? Well, the left is talking about the object that is actually calling it. So if I'm an object A, this is the one on the left, then it's my responsibility to call the plus quote unquote function Oh, you know what? That's I must have moved that, or maybe I goofed. Okay, so A plus B. So I'm A and I'm calling this plus on B. So the way it actually converts this to in memory is it would be A dot, just like it were a function call, and it would do this. That's actually what it replaces this whole thing with. So you have the thing on the left, operand on the left, the operator, which is the function call, and then the operand on the right, which ends up being the parameter. Now, the left operand of the overloaded binary operator is calling the object. The implicit left parameter is accessed through the this pointer. So when we say this, you're talking about the object itself. So A is implicitly calling its this on B, basically, or being passed into this. So it's behaving like it's the one on the left, and then the parameter is the one on the right. Now, the implicit left parameter is accessed through the this pointer. So right here, OP sum, I created the sum here. So the left's value X plus R, whatever the parameter that you passed in, dot X, and then return the sum. Okay, so we can invoke it. You could actually directly call it like this, like I had mentioned earlier, or you could just use the more conventional manner, which is this. So you can actually call functions for operators like this. No one does that because this is much more simple, far less keystrokes. Okay. So overloading, the assignment operator can solve problems with object assignment when an object contains a pointer. Remember, we discussed that and said that that's a big problem. If one of your fields in your class is a pointer, you could end up pointing to the other class's object, the one that it created, and then like everyone ends up pointing to the same thing. So I would suggest that this is a good use of operator overloading, is that you can overload the assignment operator, and then it's most naturally overloaded, you'll see, as an instance member function. So inside the class it's being defined on, it needs to return a value of the assigned object so that you can cascade. For example, if you make it void, it could still work with one of these and do its due diligence. But what it needs to do is it has to return an instance of itself, like an instance of the particular class, so that you can say equals C again, and then we can cascade it like this. You can keep saying it equals D equals E equals out. Okay. Here's our operator for equals. You'll see it takes an instance of the of itself, basically the class, and then it defines it like this. So it says whatever the other guy is, I'm going to take my data P and set it to whatever, I'll copy whatever data is in R. And then what it does is it returns a dereference on the this object. Okay. So invoking the assignment operator, again, they're showing you the two alternate forms there. Okay, so you can say a dot operator equals and then pass it X and A equals X. Now, again, if you don't recall, this is an alternative syntax here, or a syntax available for setting the value for X for CP class to 45, or passing a 45 into it, because we didn't have the default value. We did for this one. So it calls the default, or rather a no argument version of the constructor, so that it just uses this default value of 0. But the second one, you'll notice that it does in fact uses 45. You could also say, X equals 45 later on, as long as it's mutable, but this is how you call the constructor on it. So that's the copy constructor. Or that, I'm sorry, this is just a regular constructor. This is the equals operator. Okay, notes on overloaded operators. So overloading can change the entire meaning of an operator. Most operators can be overloaded. You cannot change the number of operands. So I already went over that. Like if we have an equals and it is always binary, you're not going to have a situation where you can say, hey, equals, I want to turn you into a unary operator or a ternary operator or something like that. So overloading, though, can change the entire meaning of an operator. We said that, again, most operators cannot be or can be overloaded. Some cannot. For example, the ones that they show at the bottom, the ternary operator, that's the conditional operator, the dot itself, you can't overload it. You also can't overload dot star or size of. Size of is considered an operator itself. The reason is because the ternary would make it more complicated. The dot is used everywhere to access members of objects and stuff. And if you redefined it, you could really shoot yourself in the foot, and then you wouldn't be able to actually, none of your code would work properly. It would never do the right thing. Overloaded operator is a member function of the class. So access to the private members and use of the this pointer. An overloaded operator, what would happen if you made an overloaded operator as a separate function outside of the class? We must declare the operator as a friend of the class to have access to private members. So remember I told you earlier there is a scenario in which the friend function, the friend keyword, is generally accepted as okay and useful. This is it. And it's if you have an external function that you basically have the class declare as a friend so it can overload an operator. And the first question might be, well, why would you even do that? Because can't I just define it inside the class? And the answer is yes, but riddle me this, Batman. If I delete this here and I have, let's say, a class called, now let me see here. You know, here, we'll make it circle. Let's say there's a circle class and we set some values to it and do all kinds of stuff like that. And then let's say I have an integer sum val equals 10. We'll say that C has had its radius set. Let's say that the radius in C is 50, okay? And let's say you want to define an operator to allow you to add a circle plus an integer. Like, what does that even look like? Well, you can do the circle operator plus, and then, you know, circle, or no, int other, like that, something like that. And then you can take care of the data or the behavior inside of that. And what that would do is if at any point you created your circle C and I said C plus some val, like that, that would work fine. But the problem is it does not automatically take care of the opposite situation. So what happens if I do some val plus C? In other words, the circle is the second operand, but the integer is the first operand. It does not automatically, it's not automatically symmetric. So you have to actually, you would have to define a function, an additional function that takes both parameters, but takes the integer as the first parameter if you want to make it symmetric, have symmetric behavior. Here's the problem. Anytime you declare something with, say, this, like the circle, for example, and I have C plus something, this one works because you remember it overloads this and it allows you to do something like that. Okay, because it assumes the right, or rather left side, is C. Okay, the left side is C. The right side is some val. The problem here is that the left side is some val and the right side is C. And there's nothing really I can do here. So it's a little bit more complicated. And then you might think, well, can you modify the class on the left? Well, you may not have access to it. And in this case, it's not even a class. It's integer. So the way we get around that is you can actually create an external class or external overload, and it's going to take integer, the int, and then maybe circle, the circle, like that. And in that case, what it'll do is it'll allow you, as a friend function, it'll know that you're talking about, hey, the circle, when I add an integer as the first argument, to the circle, which is the second, or we'll say operand, it will then account for this type of thing down here. Okay, this subval plus C. So that's really the only use for it, is to basically make the object upon which the operator is called on the right side, make that doable, because otherwise it would not be doable, because there's no way to do it inside of the class to get it to work right. Okay, the increment and decrement operators overloaded differently for prefix versus postfix notation, so you have to be able to do that. And you might think, well, wait a minute, how do I distinguish between prefix and postfix? Well, they have a clever way of doing that too, which I think we'll see in just a minute. You can overload relational operators. You can also overload stream operators, like the extraction operator, stream extraction operator, and stream insertion operator. You're using an overloaded operator to make an overloaded operator. You could, but you can continue to overload it and change its behavior. So in this case, what we have here is the overload stream operators. They have to take iStream, OStream. We all scream for iStream objects. These are best overloaded as standalone operators instead of members. Okay. You can overload the brackets as well, so you can make your class behave as if it was like an array like structure. That would be possible. Okay, any questions on that so far? This is kind of lost. Which part? Operator overloading is a little bit complex in some ways, so it does sometimes take a little bit of looking at it. All of the operator overloads. So you don't understand what they're trying to do, or?
Yeah, it's fine. We can move on. I'll go back and review it.
Okay. The idea behind it, do you get the idea why we would want to do this, or is that the problem, or is it how it's done?
I think that's part of the problem, is like.
Okay, so if I wanted to be able to add two circle objects together, and I wanted to define what does that mean if I add two circles together. So if I delete this, for example, and let's say I have a circle C and then a circle. Okay, let's do this. Let's say they take radiuses, radii, I guess. Circle C and circle C2, and then maybe that has a radius of 5. Okay. By default, there's no way for me to define, if I want to create maybe a circle C3, if I have to do C plus C2, that doesn't really make sense. You're going to get a compiler error for multiple reasons, because it doesn't know how do I set an circle equals to whatever is the result over here. It doesn't know what to do with the result over here. How do I even create that result? So the big situation here is, how is there a way for me to define what does addition between two circles look like? And C++ allows us to take a syntax that's very similar to function, and to say, if I have C and C2, and inside the class, you have it return a circle, a new circle, and it's the plus operator. And we're assuming, if this is coming from inside the class, that I'm the one on the left, so whoever's calling this operator, and then this guy is the one on the right. So this basically gets converted. Instead of C plus C2, like this, it actually is the same as if I had typed C dot call this function on C, and then pass as an argument C2. So it's just more streamlined syntax. Now, Java, you don't have operator overloading. It's not available. So with Java, you would have to come up with a completely separate function like add or whatever. But this is really just a convenience of syntax. It's also one of the reasons Java doesn't support friends, like friend classes and friend functions, because it doesn't have to. Because that's really the only good use for it, is when I start overloading operators. This is considered a more advanced skill, and it is something that you wouldn't do very often in most cases. It's not really that difficult once you get used to it. But if you, for example, here's another example. Let's say, do you know how we take it for granted in some of the code we've written so far, I can say string my name equals John. And then later on, I might say something like see out my name, like this. That looks like very, very simple code to us. We just create a string, set its value to John, and then we're going to print out the string. But the fact is that this class string is not actually built into the syntax of C++ itself. So they had to actually define a couple things here. There's actually two operator overloading going on here. One, it had to know, how do I convert a C string, which is just a series of characters in memory, basically a pointer to a bunch of characters. How do I convert that to a string class? And it had to, so the string class defines that. And on the other side, it had to tell it, how do I overload this operator right here to tell it, how do I send a string to the output, or how do I send a string to the output stream? So what's actually going on here is this is cout dot operator my name. That's actually what it gets converted to, and then cascades, because we have to do it again for endl or something else. But if you come up with a special data type like circle, and you want to just be able to do this, maybe cout my circle, and have it actually compile and work and everything, then you have to overload the operator, the stream insertion operator, so it knows how to handle a output object like this, and then the second argument or second operand being a circle, because the developers of C++ had no idea you were going to even create the circle class. So how do I even do that? And that's where some of this comes in, is the ability to change the behavior of operators that we currently have to work with new data types.
Okay. All right. Thanks.
Yep. Stream insertion. The stream insertion operator missed the class. Yeah, it did. It really did. It needed redefined so it could understand it. Okay. So yeah, we can overload that. R values, this is more of a new feature, so we're just kind of jump over this. It just allows you to create a temporary value that's unnamed. So it's kind of silly. It's used for the assignment statement, then the memory is deallocated as inaccessible. But this is, if I want to create, okay, so if I want to do an R value reference, I can create a reference to an R value with double address of operators. They look like the address of operator. Declaring the R value reference assigns a name to the temporary location holding the value of the expression, making it no longer an R value. So some of this stuff is just, it's kind of esoteric. We don't really need most of this most of the time. Other stuff introduced though in C++ 11 that we need to keep track of, or be aware of at least, are that there are copy assignments and copy constructors. They're used when objects contain dynamic memory. Deallocating memory in the target object, then allocating memory for the copy, then destroying the temporary object, and it's resource intensive. So what they've done is they've come up with something called move semantics. There's move assignments and move constructors, which use R value references. So they basically kind of temporarily point to something for a little bit and then are able to return it when it's done. So let's see here. Yeah, moving's not new. Basically, they introduced it in C++ 11. Move operations have already been used by the compiler. So non-void functions return a value when the right side of an assignment statement's an R value, and on object initialization from a temporary object. So don't worry, I wouldn't worry too much about those. Type conversions, I think some of these are newer too. Yeah, that's mostly just other stuff related to operator overloading. Let me see here. Use of construct, convert constructors. Now this will be something that we'll want to know. I would suggest we take a short break and then come back and work on the remainder of this. So we'll start here when we get back. So let's do about a let me see, yeah, 15-esque minute break. We will delete these for now, and we'll say break until 7:26 p.m. Okay, so we got that. And all right, break until 7:26. I will see you all back then, and we will look at aggregation and composition, so which is an object-oriented feature. And then we'll get to polymorphism. All right, I'll see you guys in a little bit. Thanks. Righty. So we are back. A little bit of information for you about some object-oriented features are the concepts of aggregation and composition. So if you remember, I said that the three primary principles of object-oriented programming are encapsulation, inheritance, and polymorphism. So even though aggregation and composition are considered object-oriented features, they are not any of the three primary features. So class aggregation means that an object of one class owns an object of another class. And class composition is a form of aggregation where the owning class controls the lifetime of the object of the owned class. So supports the modeling of a has-a relationship instead of an is-a relationship like an inheritance does. So for example, we might say that let's say we have two different let's see here. And I'm going to do that. Okay. We've got two different scenarios here. And one of them, we have an animal and dog and a car and an engine. Okay, so we would not say, for example, that a car is an engine or an engine is a car, but it would be correct to say, for example, that a dog is an animal. So I would say that we can use this symbol right here. This indicates that this is inheritance. This is an is-a or is-an relationship. So this is inheritance. A dog inherits from animal, meaning that it possesses properties that animal contains and then has some of its own. This is inheritance. So this is required for all object-oriented, for a language to be truly object-oriented. Over here, this is an object-oriented feature, but it is not the same. The symbol in UML is a little bit different. So we use a diamond rather than a triangle. And we would say that a car has an engine. So this is a has-a or has-an relationship. So it's a little bit of a different situation, right? Because the car, how we would actually make this happen is in C++, you would use a colon. You would say like my class and then your class, right? With a colon in between. And then in Java, you might say something like my class extends your class. Okay, so this indicates an inheritance relationship. However, over here, it would be something where the class might have a private data member. So the car class, oops. So the car class at some point, ... and then later, maybe it has private data and it would have an engine called, the engine or a pointer to an engine or something like that. And that would be a has-a relationship. So the car has an engine. Okay. So that's a composition or aggregation relationship. So here's a composition example that they give. They've got two different classes. They've got one called student info, and then they've got one called student. You'll notice that student info has things like first name, last name. I would not do that. I would put a lowercase l. I know that's confusing, but don't put capitals for variable names. For here, you've got the string address, city, state, and zip. And then you've got a class student right here, and this has as part of its private data a student info. Okay, question is, so what is the difference between aggregation and composition? Okay, so composition is generally considered as a stronger version of aggregation. So for example, let's see here. So car has an engine versus, let me see here, let me think here. I will grab this and we will do this here. So car versus engine versus, okay, a pond and a duck. So, I always forget which one's which. I think composition has the filled in diamond, but let me double check here. Okay, composition, aggregation, UML. I got to make sure I've got the right UML symbol so I don't lie to anyone. Okay, yeah, composition, yeah, I was right. Okay, yay. Okay, so composition is actually more like this. So composition is a stronger version. So that would mean that, for example, with the pond and duck situation, if the duck leaves the pond, it could go do other things and doesn't have to live in the pond, and the pond will survive without the duck. Over here, it's a much stronger connection. Okay, so the engine doesn't just like go off on its own and do its own thing. It doesn't really have meaning outside of the context of the car, whereas the duck does. However, we would at some given point in time both say that the car has an engine and also the pond has a duck. Yeah, when we start talking about needs, Brian, one of the students said that a car needs an engine. That is true. It does show a stronger component to it. I guess that would actually be, that would probably be a pretty good way to look at it. One would argue a pond does benefit from a duck. Needs might be a strong word, or that a duck needs a pond. It does need water, but it can go to a different source of water. Now, obviously you could rip the engine out of one car and put it in the other. But once it's actually installed, it's not as fluid to just move anywhere it wants. Okay, it would have to be, it's a big undertaking. Whereas over here, the duck just gets to kind of, do whatever it wants. Okay, or if it's a goose at like the U of M Dearborn campus, they'll just walk in front of you as you're trying to drive your car out, and you can beep at them and they'll just honk at you. It's really irritating. But anyway, yeah, so same thing. So goose needs campus, campus needs goose. I don't know. That's probably more aggregation. Yeah, aggregation's a weak form of composition, or composition's a strong form of aggregation, whichever you want to look at them, but they both model a has-a relationship. Okay, here we go. Other things that you can use. This is used in constructors for classes involved in aggregation. It allows a constructor for owning class to, I would say that is owning a class, to pass arguments to the constructor of the owned class. Okay, so for example, if I have a car over here, so I have car and then some parameters here, I could then just say on the constructor, colon, and then the name of the engine class, and then pass it some stuff. I might say comma carburetor, comma transmission, and then pass them parameters, and we can initialize their objects this way. That's actually considered often a preferred technique to do it. So member initializer list might look something like this. Or member initialization list rather. So you've got your student info, and you've got this. Let me see here. 1 second, I'm answering something. Okay, the class student over here, which has a student personal data, and the student info personal data is part of the private data here, but we are actually able, since this is an aggregate part of student, to call students constructor, and then we can actually pass it on to this data member, personal data, which is being aggregated using its constructor. Okay, so it has a constructor that clearly takes maybe a first name and a last name as well. Let's see, I thought I saw someone said something. Maybe not. Okay, so a has-a relationship can be implemented by owning a pointer to an object as well. So not just the object, you could just have a pointer to an object, and you can have an aggregation type relationship there. Generally, when we speak of it, some people will actually use the terms aggregation and composition mostly synonymously, but there is that difference. So This can be used when multiple objects of a class may have the attribute for a member. Using pointers minimizes the data duplication and saves space. Aggregation represents the owner-owned relationship between objects. Composition is a form of aggregation in which the lifetime of the owned object is the same as that of the owner object. So the car dies, the engine dies, okay? The pond dries up, the duck doesn't necessarily die, it may just have moved to another pond. That's basically kind of the idea. So the owned object is usually created as part of the owning object's constructor and destroyed as part of the owning object's destructor. That's composition. Okay, moving on from there, we have talked about the 3 primary principles of object-oriented programming. Okay, 3 primary principles of OOP. And we know that they are encapsulation, which we should know already, inheritance, and polymorphism. Morphism. There we go. Okay, I really can spell. Okay, now, so encapsulation, we discussed that and talked about how this is kind of a, how we are able to put data and behaviors together, right? So you've got data plus behaviors. Okay, and that this gives us some security because it protects the internal data from being accessed in ways that we don't want it to, as long as you don't, give it a friend function. Although you should be careful with that. And it also gives us portability because we can now treat maybe several pieces of data as a single entity. So I might have a car object and not have to have 160 different pieces of data having to be about that car as separate. And then when I make a new car, I have to make another 160 pieces of data completely separate. So they are encapsulated or integrated together in such a way that we can treat them as a single unit. And so we did talk about the encapsulation before. So encapsulation is kind of all those things. Inheritance is a form of software reuse in which we get to have the same behaviors that we inherit from our parents' parent classes. So it's a way of creating a new class by extending or adding new members to an existing class without modifying the original existing class. So the new class can replace or extend functionality of the existing class, meaning it can take its functions and member functions, methods, and modify them, or it can create, can create its own additional ones that the original class didn't have. So animal may have a make noise method, but maybe it doesn't have a bark method or a eat dog food method or something like that. Maybe it has an eat method that's more general sounding, but then when you have maybe 2 classes that inherit from animal, cat and dog, and bird, maybe there's a third one, maybe all 3 of them have different implementations of eat. Okay, the bird eats the seed and does stuff after that, and then the dog will eat pretty much anything. The dog will eat dog food, and then the cat will eat cat food. Okay, so they might have different behaviors associated with their eat method, but they all share in common the fact that they have an eat method. The existing class, when we're talking about inheritance, unlike encapsulation, where we can usually just refer to the single class, where we talk about data and behaviors of a single class and then instances of the class being objects, with inheritance, we're talking about a relationship between 2 classes at any given time. The existing class is called the base class, and the new class is called the derived class. So I would say, for example, if I had animal, I have this right here. Okay, let's actually move this up here, split that down a little bit. And let's say I have an inheritance relationship here. And this is, I use animal and specific animals more often. Let's say vehicle. We'll use a different example, vehicle. And then we're gonna have, for example, car, okay? And then maybe there's another one somewhere along the line we come up with. I've had students argue with me about this, but I'm gonna say a boat is a type of vehicle because it gets you from one place to another. Bike, boat, car, truck. I have a mechanic friend and he gets very upset if you call his truck a car. So they they are all vehicles though. So you might have boat, you might have truck, you might have van, you might have bicycle, you might have motorcycle, all kinds of different things, right? So, but we would say that vehicle is the base class. This is the term that we typically use in C++ and C#. And we would say that these are down here derived classes. Car is a derived class of vehicle. Boat is a derived class of vehicle. Yes, modes of transportation. And we would also say in Java, if we were using Java, we would generally call this the superclass, and we would call these the subclasses. So superclass, subclass, base class, derived class, it all technically means the same thing. The most kind of real general terminology that people you'll hear use, because it's kind of like a family tree in a lot of ways, is we would say this is the parent class. So vehicle is the parent, and then boat and car are the children classes or child classes. Okay. Here's an example. We've got this class called base, and typically we're going to do what's called public inheritance. So you put :public base. They may cover the difference between public, private, and protected, but that's a little bit outside the scope of what we really need to do. But we've got this class base, and then the derived class inherits publicly from this base class. Objects of the parent, yes.
So is derived the keyword then?
We would, no, derived is not a keyword. There's a colon.
Oh, the colon. Okay.
Yes, it's like the extends keyword in Java.
Okay, so
except
it's the colon, not derived. Okay.
Correct. Yeah, derived is the name for it. The in Java we would not have, for example, okay, this is annoying. One second. We would just say extends base. We wouldn't even put public or any of that because Java only has public inheritance, so there's not really any way to distinguish it. C++ has what's called public protected and private access, private inheritance. Those are not used very often, and they cause a lot of confusion. So a lot of people just avoid them altogether. But yeah, that's a derived class and base class. So the objects of the parent members. So if I have a parent, this is data inside the parent called int a, and then void bf. Okay. And then over here in the child class, we might have a data seek and then df. And the objects of the child, this one actually would inherit if this is public. Okay, if this is public access, they kind of wrote this wrong. This should actually say public before these, because by default these would actually be private. But the child class would actually have access if these were both public to A and this function or method bf. So you could actually create a child instance, say child, my child, and then later on say my child dot df, but you could also say dot bf because it has inherited from the parent class. So dynamic allocation of objects, we've kind of talked about this before, and this is going to eventually lead us into the polymorphism discussion, because you have to understand inheritance before we understand polymorphism. When dealing with inheritance, objects should be created using dynamic memory and accessed via pointers to the allocated memory. A method that expects an argument of a base class may not have the space needed to accept an argument of a derived class, even though an object of a derived class is an object of the base class. So using pointers to objects instead of objects for parameter list and arguments can actually overcome some of these issues. Protected members, this one is, again, I wouldn't say controversial, but it's generally frowned upon. They some people consider it, not to get into too advanced of a discussion, but a lot of software engineers consider using protected part of an anti-pattern, meaning it's bad design, because you're giving access to descendant classes, meaning a child class or a child's child class or a child's class. You're giving access to them, to your data that should otherwise have been private. But sometimes, people will use this. It's kind of a middle ground between private and public. So if it's labeled protected, it means it's accessible to member functions of the derived classes as well as to the members of the same class. So it's kind of like, now if a class completely outside your hierarchy, let's say the main method, or not even a class, but a function, completely outside of the hierarchy of your class tries to access a protected member, it's the same as if it were private to them. So if rectangle, let's say rectangle had a subclass or a derived class called square, and it made its width and length protected instead of private. That would mean that square would still have access to length and width, but if main function, which is not part of either of those classes, if the main function creates an instance of a square or the original rectangle, it's as if they were private. So it doesn't make any difference for the main function. It still protects them. So basically it's stuff that is kind of private within the same inheritance hierarchy, but it is, I would say private to the outside, but it is public within the inheritance hierarchy. That's what a protected is. So similar to private, except accessible to member functions of derived classes. Now, if you have an animal class or any kind of base class, animal or vehicle or what have you, and they have a private member, then none of the child classes can access that data directly. They have to go through whatever means you provide for them, just like any other class or function. This is the base class access specification, and that determines how private, protected, and public members of the base class. This is what I was talking before when I said up here, how we have to put colon and then like public parent instead of just colon parent, colon public parent. You could also put private or protected, and that actually has implications for the access of the data. So these are the 3 inheritance modes. This is by far the most popular. That's in fact the only one that Java allows. That's why you don't have to put the public keyword. So when I say something like this is only what Java allows, again, if you've never had Java, don't worry about it. Don't sweat it. It's just, this is kind of additional information for people who have had Java. And also, it should also give you an idea of what were some of the things that when they created the Java programming languages, they found language and actually some other subsequent languages, I guess, that they found to be either not useful or too confusing. So they removed it or did not add it to the new language. And this is one of the things that Java decided not to, the people that created Java decided not to include, is different modes of inheritance. But C++ does still have it because it's been there since the beginning. You can have public inheritance, protected inheritance, or private inheritance. And really what it does is a public inheritance, let's say the parent has public methods. Let's say it has all 3. Let's say it has public, private, and protected methods and data, we'll just say. So public just means it becomes same in the child class. So for example, if there was a public method called do something in the parent class and the child class inherits it, then if anyone creates an instance of child, they can call do something on it just as if it were public. However, if you do protected inheritance, what that does is that means that the child class does inherit all of the public and protected stuff from its parent, but everything becomes protected. Okay, the private's still not accessed, but if you try to access something that was public in parent through child, but and it's through protected inheritance, but it was a public method, when you access it through child, it has to be only accessed as if it were protected, meaning child's children can then access it, but no one else can. And then private's the most restrictive. That basically means that even if it were public inside of parent, child cannot child can access it, but anyone who inherits from child cannot access it any further because it will be as if child had declared them as private. And also you can't access them outside of the class. So that's one of the reasons I know for a lot of you, you're like, what the crap is he talking about? Exactly. That's why we don't usually talk about it. We don't usually spend much time on it. It's one of those things where kind of just making you aware there are different types of inheritance. So if this kind of ever rings a bell when you've had like 5 years, 6 years of experience with C++, this might be something you'd want to revisit. after a couple years, even 2 years, I'd say, of C++. But it can be very, very confusing. And what are the actual use cases and all this other stuff? The fact is you don't have to use these two in pretty much any instance. We can always get away with public inheritance, and you can actually probably have a better design if you're careful from the beginning rather than having to rely on some of this junk, which is why Java removed it. Okay. Base class access is not the same as member access specification. Base class access determines access for inherited members. Member access specification determine access for members defined in the class. Let me see here. Oh, I think they're giving yeah, this is kind of the effects, like the summary of the stuff I just talked about. So if it's public inheritance, or public base class access is what they've been calling it, then that means the object of the derived class can be treated as object of the base class. If it's protected, it's more restrictive, so that allows derived classes to know some of the details of the parents, meaning it inherits all the stuff as protected. Private prevents objects of derived class from being treated as objects of the base class. And then they give you kind of a visual diagram of what's going on. So it's essentially the same stuff. Further, kind of, I think the last home stretch of this is the constructors, destructors, and inheritance. How do they affect one another? What happens? By inheriting every member of a base class, a derived class object contains a base class object. Now, not in the same way as aggregation, but it basically means that it has created an instance of itself when you do a derived class, but also kind of behind the scenes, a base class object is being created as well that's associated strongly with that derived class object. The derived class constructor can specify which base class constructors should be used to utilize the base class. When an object of the derived class is created, meaning like if you create a dog object, the base class, like animal, its constructor is executed first, then the derived class is constructor. So if I put a print statement inside of animal class and one inside of dog class, and then created an instance of the dog class, it would call the animal class constructor as well. So let's do something like that. So we're going to make this kind of very short and sweet, just so it's obvious what's going on. We'll have main here, IOStream. And main. Okay, and then over here in header file, I think in this case, I'm going to just for giggles, we're going to do them all in .h file. We'll do, let me see here, animal.h. And I'm going to do if in def animal h, define animal h, and then in diff class animal. Okay. And let's say I'm not going to even do too much work into this. It's literally just going to have a constructor. And let's, I guess I have to also include IOStream so I can print stuff. IOStream using namespace standard. And inside of the constructor, the animal constructor, I'm actually going to just say cout I'm an animal. Okay, and then I'm going to make a destructor just because that is called when we go out of scope. We're not doing Java, so let's do that. Okay, and then let's say animal has been destroyed. That sounds really dark, doesn't it? Okay, so we've got that stuff. And then what I'm going to do is I'm going to go over and create another header file. And we're going to call this one dog. Okay, and we've got if in def dog underscore h, define dog underscore h, and if, and then we'll do class dog inherits from animal. Now it won't be able to see this yet because I haven't included it, but I'm going to do that. We'll include animal.h. I'll also include IOStream, and that's using namespace standard. And kind of the same thing here, I'm going to make a public section. And I'm going to have a dog constructor, and this dog constructor is going to print out, I'm a dog, woof. Okay. And then the dog destructor, doggy has left the building. Okay, that's our destructor. Okay. And that's the only two. Now, because dog inherits from animal, let's kind of see what goes on if I create an instance of dog. All I got to do is create an instance. Literally, I just have to say dog d, just like that. And then I'll say, oh, I guess I got to include dog.h. Okay. It doesn't really matter if it's above using namespace standard, but I'm going to put it there. Okay, so all I did was create an instance, and that will automatically call the constructor, the no argument constructor of dog. And since we've redefined the no argument constructor, it will do this. But before it calls its constructor, since it also is inherited from animal, it will automatically call animal's constructor first. So let's see what happens when I build this. So one little line of code here inside of main, and we'll see if we get some interesting behavior. So first it calls the constructor from animal, and then it calls the constructor from dog, right? Then it calls just dog's destructor at the end of main because it's about to go out of scope, or it goes out of scope. And then after it calls its destructor, it calls animal's destructor. Okay, so that's the order of things. That's what they're saying when they say that the base class's constructor is called first and then the derived classes. If you had 3 levels, like I had another class called poodle, let's say I didn't want to just indicate it with a string or whatever, and I wanted there to be specific poodle features, and I inherit from dog as poodle is the subclass or the derived class of dog. Then what that would do is that ensures that poodle would then have animal called first, and then dog, and then poodle. And then on the way out, when it calls its destructors, it would call poodles, then dogs, then animals. So that's how kind of the order goes. So is this sort of like the Android lifetime where things end from the inside out? Kind of, yeah. This is at a lower level, whereas the Android life cycle has actually been determined by the Android runtime. This one's kind of similar in that, but this works for classes regardless. You have regardless of whether it's part of another framework or not. With classes, you're always going to have a constructor, and then it's going to do something upon destruction. So it is very similar, I guess, in that respect. It is part of what we would call the class or the object's lifetime. So it is very, I guess, could be highly analogous to what's going on in, say, the Android lifetime or the iOS runtime or iOS lifetime, or any other framework. So it's very, very similar. Okay, the order of execution I just explained, so I'm not going to cause a problem here. Okay, the passing arguments of the base arguments to base class constructor. This allows selection between multiple base class constructors. You can specify arguments to a base constructor on the derived constructor heading. You can also do it with inline constructors. This must be done if the base class has no default. So for example, if I go over here and let's say animal has a constructor, but the only constructor it has, takes an integer like, I don't know, num legs or something like that. Maybe it has some data it's going to pass in at some point. You'll notice that dog has an error already. It says no default constructor exists for animal. And then over in main, if I try to build this, it's going to complain at the class level. So it's, again, same thing, no appropriate default constructor found. Because dog is trying to call animals version that only takes, or that doesn't take any parameters. But if I do it this way, I can actually say, I can tell animal, well, here's your integer that you were waiting for, and then it will compile. Okay, so you could pass through using an initialization list. Okay, but for our purposes, we don't really need it. So we're going to delete that. Overriding base class functions. So overriding, whenever you hear this, overriding is different from overloading. Okay, so we have to get the term straight. Overloading is when something has the same name, but different parameter list, either in terms of the order, the data types, or the number of parameters, or some sort of combination of those. That's overloading. Like operator overloading, we just talked about, function overloading. Overriding sounds similar, but it is very different. In this case, the signature of the function is the same as the parent class. And overloading can occur between base and base and derived class, and so can overriding. But overriding can only occur between base and derived class. Overloading can occur within the same class or among multiple classes in the hierarchy. Overriding means a function in the derived class that has the same name and parameter list, i.e. it has the same signature as the function in the base class, typically used to replace the functionality in the base class with different actions in the derived class. This is, again, not the same as overloading. With overloading, the parameter lists have to be different. Okay, when a function is overridden, all objects of a derived class must use the overriding function. If it is necessary to access the overridden version, you can use the name of the class and then the scope resolution operator. So for example, if we go over back to our example over here, I'm going to kind of modify animal a little bit here. I'm going to make a function called make noise. Okay. And all it's going to do, we don't really know what a generic animal sounds like. So it's going to be some like really creepy thing like gurgle, gurgle, like that. Okay, so the generic animal doesn't know how to make noise or what it's supposed to sound like. But then now if I go over to main and I say d.make noise, do you think it's going to go gurgle, gurgle or not do anything? What do you guys think? Is it going to actually call the one it inherited from animal? Yes. Okay, thank you. Let's see here. Waiting with bated breath. And of course, it's doing the constructor thing, and then in between, during its lifetime, it went gurgle, 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 which is what we expect. The other issue is, let's say if I have dog, well, this is dog, okay, and it does make noise. And if I, inside of dog, did not have a definition for it, it'll use the one that was inherited from animal. However, if inside dog I have something with the exact same signature, it goes woof woof. Okay, and I build it, and then I run main. It's now not going gurgle gurgle anymore because it has overridden the behavior of its parent with the same name of the function. I didn't change anything inside of main. You'll notice. Now, if I say animal, anim, and then I guess this has to inherit or include animal too. It should. It will actually work because dog includes it, but you should explicitly include, what am I doing? You should explicitly include everything that you're using, even though indirectly dog includes animal, so it was letting us get away with that. You should always put what you're using up here. And that's another reason why we put the include guards, is so it doesn't get actually included twice. So if I have that, and then let's say I have anim.make noise. So I've got the animal making its noise after the dog. Let's see what happens. Okay, we're going to do. Okay. So the dog goes woof woof because we called d.make noise. And then the animal goes gurgle gurgle because that's its definition, right? Now, an interesting question might come up, which we'll talk about in a minute. What happens when you use pointers? And that will be an interesting name as well, or interesting situation as well. But we'll talk about that in a minute. Okay, so that's the end of those slides, and we're kind of segueing into polymorphism. Are there any questions about anything we covered thus far? I know there's a lot, and a lot of it's a little bit more confusing than other things, but as long as you get kind of the general idea, you know the basic syntax of inheritance, you know the basic idea behind aggregation and composition, you should be good on that. But are there any questions before we move on? Because polymorphism is the third of the primary principles. Prefer composition to aggregation. That completely depends on the situation. Aggregation, composition is a type of aggregation. So it's just a stronger type, and it entirely depends. It's kind of like the duck pond example. If it doesn't need to own it, I would say you would prefer aggregation, but in some circumstances you do need to completely control the life cycle of the underlying aggregated or composed data. So if that's the case, you would prefer composition. So polymorphism is our next thing. And in Greek, someone's asking a question. 1 second. Let me see here. Okay, yeah. So what we would do after we understand inheritance is we would want to understand polymorphism, because encapsulation is one of the things that helps us understand inheritance, and the inheritance then further helps us understand more complex things like polymorphism. Okay, so each of them builds on one another. So that's actually one of the reasons that I would expect that we would learn it in this particular order. So that is preferred. So anyway, polymorphism is the Greek word for many forms. Okay, many forms, or the state of many forms. A polymorphic object can take on many forms, and this allows us to, for example, use a base class or a superclass variable type to hold a pointer to a derived type. Okay, so at first, let's take a look at what we can do over here. If we do a little bit of modification here, I'm going to change these to pointers instead of, you know what, actually, I'm going to leave these and I'm going to create new ones. This time I'm going to use pointers. So we'll say dog pointer, I'll literally call it dog pointer, equals new dog, and explain ditto. Oh, someone said ditto, explain ditto. Oh, okay. That was a Pokemon reference. Sorry, I'm not as big on my Pokemon as I am my Star Trek, so that's I'm not as up on that. Okay, so delete dog pointer. All I know is that I've been told I look like Snorlax, but I don't think that's very nice. Anyway, okay, so dog star, and then we have animal star. Animal pointer equals new animal. Okay, and then we're going to eventually delete the animal pointer. Now here's some magic, right? We're going to say cout dog pointer, or no, not cout. That's right. It already does the cout, right? It doesn't return a value. It just literally calls make noise. So dog pointer does that. Animal pointer can also do it, right? So they both do this just like when we were using the directly using the object rather than doing it through a pointer. In these situations, we can call make noise on the pointer. So if I run this, I have dog being called first, which is why I'm getting woof woof, and I have animals make noise being called, which is gurgle gurgle. Okay, really cool. But here's a third scenario, a third possibility. Animal pointer, okay, equals a dog. No compiler error. Okay, no compiler error. So I'm going to I'll briefly comment these out just because I want us to really focus on what I'm about to do. And I'm going to do poly pointer make noise. So here's the question. Here's the big question on the table. In this case, you'll notice that animal, yes, all animal functions, since they're public, can be used inside dog. That's whether it's public or not, but not vice versa. If dog had, for example, a chew up toy command or chew up toy function, and I can't access that directly through an animal pointer because the animal only knows about methods that it has defined. But the fact is that animal and dog both have make noise. There's overriding involved. So here's the issue. I have an animal pointer. Okay, so this is animal pointer, but a dog object. This is called a polymorphic reference or polymorphic pointer. Okay, because I am using the fact that there's an inheritance relationship between dog and animal. Remember, a dog is an animal, and because of that, a dog object can be pointed to by an animal pointer. That's totally fine. Or a cat object could be, if I had a cat class that was inherited from animal or bird or what have you. So the fact is, since they both have make noise, I can call make noise. The question now, it was not in question before, because the dog pointer called its make noise, the animal pointer called its make noise. There was no question whatsoever that they would call their respective versions. So the question now is, which one is called? Is it going to call the animal noise because the pointer is an animal? Or is it going to call and say woof woof, or I'm say gurgle gurgle? Or is it going to use the objects version and go woof woof? Okay, so some people think woof woof, some people think gurgle gurgle. Okay, a lot of good guesses. Let's see what happens. I'm going to build this. It's not going to go meow. Sorry, Brian. When I run this, it's going gurgle gurgle. So it's using the animal's version, not the dog's version. Okay. Now, if this were Java, and I said something, so for those of you that have had Java, let's say I have a Java reference to animal, and then I say dot make noise, because you don't use the pointer syntax in Java. In Java, it'd go woof woof. Okay, because in Java, it automatically uses dynamic binding, and that's a term. That's a term referring to when does it bind this method call to a method definition. If it's at compile time, it doesn't know anything about the object that's created at runtime. Remember, new means that's not going to get executed until runtime. So the polymorphic pointer, the only thing it knows about is its own animal version of make noise. So it only knows to call the animal version. Whereas in Java, it automatically calls the dynamic version. So it waits to bind to the definition until runtime. Good question, Todd. You said, does C++ not do dynamic binding? By default, it does not. However, remember, this went gurgle gurgle. Over here in animal, if I do a little tiny change here and put the keyword virtual in front of it, and then rerun our application, let's see if it changes the behavior. Now it's going woof woof. So in C++, static binding, or what we would call early binding, is done by default. But if we use the virtual keyword in the base class that we're trying of the method that we're trying to overload, if we use virtual, what that tells the compiler is hold off until runtime. That's when you're going to decide when to bind to the definition. And since it's waiting until runtime to bind, it then sees the object and says, oh, you have an overload. Let's use that. Yes, Todd.
So if I'm understanding, like coming from Java, if I'm understanding polymorphism correctly, then we would have to use the virtual function for polymorphism.
Well, it's still considered, yes, to get to get dynamic binding and to get a polymorphic behavior, to get it to do what it's doing right now, you have to use the virtual function. Whereas with Java, on polymorphic references, it automatically uses dynamic binding.
So it like in this example on the screen, I'm thinking, say there's the animal class, but then there's dog and there's also cat, and cat can say meow, dog can say woof, and then at runtime you would want to pick depending on whatever is passed in. Is it a dog object that's passed in or a cat object that's passed in? But that could only happen if it's a virtual function, right?
If it is pointing, yes, if it is a virtual function and you are pointing to a member of a derived class, or even with my example earlier, I said we could have a poodle class, and that could actually inherit from dog, and we could actually see that in action too. If I made a let's do this real quick. Let's make a poodle class just to show 3 levels of inheritance. So we'll do poodle.h. I'm actually going to if in def poodle, and then define poodle end if, okay, class poodle inherits from dog publicly, and then I'm going to do let me see here, public, and I'm going to do a poodle. This one's gonna go I'm a poodle being created. Okay, and then the destructor is poodle. Okay, poodle has left the building. Okay, probably to go chew on someone's ankles. And then you have void make noise. And this one, of course, a poodle does not go woof woof. A poodle goes yip yip, because it's yippy. If I go over into, oh, I also have to, I guess, include dog here, and also probably IOStream. That would help. IOStream include dog.h, and then using namespace standard. Excuse me. Pardon. And let's say, okay, so right now it's going woof woof. And then if I say new poodle, I guess it probably has to include poodle in this class too, doesn't it? Okay, 1 second. Poodle, there we go. If I call make noise on it now, let's see what happens. It's going yip yip, okay, because it's, even though there are 2 levels of hierarchy, since we declared the original one that's being inherited as virtual, it allows dynamic binding to take place. So poodle is now the object. Now, could I have a dog pointer pointing to a poodle? Yes, that would be 1 level or 1 degree of inheritance. But this works too, even though it's 2 degrees. So animal has a child named dog, and dog has a child named poodle. Or we could say otherwise, the base class animal has a derived class called dog, and dog has a derived class called poodle. Even though it's 2 layers or 2 levels, this will still work with polymorphic references and dynamic binding. The question is, the first poodle is calling the primary constructor or the poodle class? I'm not sure what you mean. Are you talking about in the poodle, Bob, in the poodle in here? Like, what is this doing, or something in main? There's only one constructor on poodle, right? Poodle only defines 1 constructor, just like all the others define 1 constructor. But what happened? Oh, okay, I see. I think I see what you're saying. So what's actually happening here is, okay, because of main, we had this dog and this animal, so you have to kind of remember that. And then what's happening is, since okay, so wait a minute, what's going on here? We got to clean some of this up. This is getting kind of ugly. Let's do this. Dog pointer. Yeah, we don't have to. Oh, I guess I should probably clean up the poly pointer. Okay, let's run this again and see what we get. Okay, there we go. Yeah. Oh, that's, did I fill in the, oh yeah, okay, I know what it's only doing that. It is, let me see here, virtual make noise dog. Yeah, it's only destroying, it's destroying the animal object. It should destroy all three, I would think, but it doesn't seem to be printing it out. I think once it destroys, well, I don't know. I'll have to look into that why it's not showing the others. It might be because it's a polymorphic reference. So right here, oh, I know. It's only calling the destructor. It's only doing what the destructor is doing because the actual pointer is an animal. So what this is doing is it's creating the animal and it goes through all the constructors, and then when it goes yip yip, that's because of the make noise version on poodle, and then it destroys the animal object. Okay, let's see here. What do we got now? Okay, so that's basically, this is basically what polymorphism is about. They're just doing this. Hey, oh my gosh, they had poodle. I swear I did not know there was poodle in here. I would have, because normally I would have picked like German Shepherd or something to do this, but that's wild that they picked poodle too. I didn't even realize this is a common hierarchy to show like animal, cat, dog, bird, things like that, but to put poodle as another level is very strange. Okay, so we can point to a new cat. You can do casting, like if I have a cat pointer that's doing something, and then later on I want to, or maybe I know that the animal's pointing to a cat, and then I want to refer to it as a cat pointer, I can actually cast it later, do like a static cast of cat, a cat pointer to the on the PA, the animal pointer, and that will actually return it to as a cat pointer. And you know, I think they freaking stole my idea, because this set of slides did not have this before I came up with this example. I think he's been stealing. I got to talk to Gaddis. He's been stealing my examples. Anyway, so, or maybe I accidentally stole his. I don't remember. But I've been doing the make noise thing for like 15 years now, and I can't imagine that Gaddis came up with it. It's probably, if anyone, it's probably Didal. Anyway, so C++ uses the declared type of pointer to determine access to the members of the pointed to object. If an object of a derived class is pointed to by the base class pointer, all members of the derived class may not be accessible. Okay, so the typecast, you can typecast the base class pointer to the derived class using a special casting. So instead of static cast, it's static pointer cast, in order to access members that are specific to the derived class. Okay, won't go too far into that. I've already gone over the virtual functions. I don't think they go over pure virtual functions, so I think we can probably ignore that. They may. Okay, here's where they talk about static binding and dynamic binding, which I already talked about. Static binding chooses the function in the class of the base class pointer, ignoring any versions in the object actually pointed to. Static binding is performed at compile time, so it knows exactly, sorry, what it's going to call as soon as it launches. Dynamic binding, the function to be invoked is determined at execution time. We would say that we bind the method call or function call to the function or method definition. Dynamic binding is used with virtual functions. And okay, did overriding, overloading. Final keyword can be used. This is used at the end of the header or prototype of a function if you want to ensure that no class is below this override. This, I think, is like a C++ 11 thing. Java can do this too. But if you want to seal the class so that no one can inherit from it, you use the final keyword on a class, and then no one can inherit from your class. C# does this, but I think the keyword is actually sealed. So there's sealed instead of final, but Java and C++ both use final. Okay, now an abstract class is a class that contains no objects that are not members of subclasses. For example, in real life, animal is an abstract class. There are no animals that are not dogs or cats or lions. So generally what we do is we create abstract methods, or all virtual functions, or all pure virtual functions. If an abstract class has at least one pure virtual function or abstract function or abstract method, then that means that the class has to be abstract as well. We do not have the keyword abstract though in C++. The way that you create a pure virtual function, if I wanted to make animal so that I could never make any instances of it is I could actually do this. I could say void virtual, or actually usually it's virtual void. I guess it doesn't really matter, but virtual void is the way I would probably do it. And then we would say equals 0. And now that's kind of weird because you're like, what does that mean for a function equals 0? Well, that's just the syntax that you use to say that it's a pure virtual or abstract member function. Okay, so an abstract method. Now, once you do that, you don't have to do anything else to the class. The animal can no longer be instantiated. Okay, so inside main, you'll notice if I tried to do this right here, let me do this here and then try to delete that. You'll notice that right here, when I try to create an instance of the animal with the animal constructor, I'm getting an error. It says object of abstract class animal is not allowed because function make noise is a pure virtual function. So you can't create an instance of the animal anymore directly. Now you might think, well, what's the use of that? And the reality is that you know how we kind of made the make noise go gurgle gurgle because we don't know what an animal's supposed to sound like with out it being a specific animal. That's the reason. Its only purpose in life, the animal class, is to define what all these animals have in common, but you should never really create an instance of the animal class. To be more specific, if I was working on a program, say for a zoo or a biologist, zoologist, or something like that, and we were writing code for them, we would want to be even more specific. We would have something like animal at the top, and then we might have things like mammals or something with animal and maybe vertebrates, and then maybe you get down to mammals, and then eventually you get down to dog. But you might go through 5-6 levels of hierarchy in the before you got to the genus and the dog, right? The genus and the species. So that's kind of the idea here, is that several of these base classes may not need to actually be instantiated directly. Now you might think, well, wait a minute though, hold the phone, you're using a pointer of type animal, doesn't that quote instantiate animal? And the answer is no, because the thing on the right is actually a poodle. Now, does animals constructor get called? And the answer is yes, because since you're creating a poodle automatically calls dog's constructor, which automatically calls poodle's constructor. Okay. It is also considered good practice. Let me see here. I just want to make sure I don't lie to you. Virtual. Okay. I don't want to lie to you, so I'm looking up something real quick just to refer to something in a book here. Class object using a pointer in the base class, non-virtual structure is undefined behavior. Okay. It is considered good behavior, no matter what class you are creating, to always make all of your destructors virtual. And the general idea is a non-virtual destructor, if called through a pointer of a type that is higher. Like for example, when I did this with dog, it's when I did that with sorry, one second, I'll collect my thoughts in a second. When I create a pointer to poodle from this animal, if I did not have the virtual destructors, it would create undefined behavior for the destructors of the other classes. That's actually why it wasn't showing up before. I had forgotten to put virtual on the destructors. So you should put virtual on them, and then that automatically makes sure that all the destructors are called as they should be. So if I left it off, it was just calling animals version because that's on the pointer type. But you have to put virtual if you want to make sure that the others get called too. And that's what we want. So we generally suggest you always put virtual on the destructor, not the constructor. Okay, so that was our pure virtual function. As soon as you have at least one pure virtual function, it becomes then an abstract class automatically because you have a function that doesn't have a definition. Now, the difference between the way we had it before and the way we have made it is that before it had a default behavior. It went gurgle, gurgle. But as soon as you make it like this, let's say dog decided not to implement make noise, and I tried to build it. That should not succeed. 1 second. Let me see here. I may have just broken something. No, it's still going yip yip. Let me see. Why is it not? Oh, because Poodle does. Okay, that's why. Since Poodle has overridden it, we're going to actually comment out Poodle real quick because Poodle did do it. Okay, so here's the problem here. Since it says Poodle cannot instantiate abstract class. So what happened is I've inherited from Dog. Dog didn't take care of it. And then Dog inherited from Animal, and Animal has said this is a pure virtual function. So basically, when you say it's a pure virtual function, which is also called an abstract method in Java, what we're saying is someone has to instantiate this because you're inheriting it as a pure, and you can't be instantiated without the definition. So that's why we provide definitions. So now, as soon as there's one definition, it's good, but we'll put all of ours back. So it's happy now. Okay, so back to yip yip, everyone's happy. It's just Animal doesn't have a version of it. Okay, so yeah, composition inheritance. Composition is appropriate when the new class needs to use an object of an existing class. Inheritance is appropriate when objects of the new class are a subset of the objects of the existing class, or a subtype, and objects of the new class will be used in the same ways as objects of the existing class. There's actually a software engineering principle called composition over inheritance. I think, let me see if I can find it. I'm sure there's something on it, but there's a composition over inheritance. I guess Wiki has something on it, but it's about using composition, a principle that classes should achieve polymorphic behavior and code reuse by composition, by containing instances of other classes and using their functionality rather than inheritance. Okay, so basically it's just an OOP principle that you can use. So there's this book from back in 1994. It was actually based on the doctoral dissertation of Eric Gamma, who is actually one of the authors, and he's part of the Gang of Four. The authors are Eric Gamma, Richard Helm, Ralph Johnson, and John Visades. And it also has a foreword by Grady Booch, who is actually a very famous software engineer person. So the examples are in C++. It's before UML existed, so the diagrams are a little bit rough to get through, but it's a good book. I would say if you want to learn more about design patterns, they still do go by this creational, structural, and behavioral design patterns. But if you want to get a better example, I would say head first design patterns is a good example. The newest version, get the one that's not like ancient. I think this one's actually that might be the brand new one. Oh, is this brand new? That may have just come out. Let me look. What year is it? Oh, 2020. I didn't even know they. Wait a minute. Do I have that one? I think I have that one. Oh, I actually do have the brand new version. So this is actually the third version. I do have it on my shelf. I knew I'd gotten one, but I thought it was the second version, not the third one. I do love textbooks. Yes, I really like textbooks. O'Reilly, the cool thing about being an instructor, one of my favorite parts, I mean, besides all y'all, and being able to teach you and spread knowledge, is I get a lot of free books. So I actually have an account with an organization called Vital Source, and they're connected with basically all of the different publishers. And I can get pretty much free books on pretty much anything I want, which is nice. O'Reilly is an exception. The publisher O'Reilly are some of the most difficult. It's the most difficult publisher on the planet to get free books from, desk copies for like evaluation. And I think it's mostly because they don't make textbooks and they just assume that people are wanting free books, which is probably true. But I would say if you're going to purchase a book on the subject of design patterns, get the head first book from O'Reilly. It's actually really good. And it's the third generation. So they go over like the observer pattern and the model view architectural pattern. They go through like the chain of responsibility pattern facade and factory patterns. I think factory method and abstract factory patterns. There's all these patterns, and basically what that comes down to is it's things that software engineers have been working with for years, and they've basically Eric Gamma collected all this knowledge from all this software engineering stuff that we've been through for these years, and basically said, okay, here are some of the kind of common ways that people put things together that we found are useful. And those have become what we call design patterns. And then if you start combining design patterns, you get something called architectural patterns like MVC. Some patterns do indicate when to use composition over inheritance and many, many other topics. So it's just a software engineering principle, and then design patterns further reinforce things like decoupling, and it goes even farther than what we would consider kind of the basic ideas behind object-oriented programming, which is composition and inheritance. Design patterns aren't like crazy difficult, most of them. Some of them are really simple. The singleton pattern is like crazy simple, but there's some of them aren't too bad, but they kind of explain in the book. The head first book is, like I said, a lot less, ironically, a lot less heady than the Eric Gamma book, which I've read through that one too. It's a snooze fest, but it's got some good material in it. But you also have to remember it was created in 1994. Design patterns are usually not a required computer science course. I would say that if you were going for explicitly a software engineering bachelor's degree or master's degree, then it might behoove you to take a design patterns course. They have them at some universities. U of M Dearborn has them. I'm not sure about OU yet. I think they probably will get one at some point. But Michigan State, I think, has one. Ann Arbor, I'm quite certain, probably has one. Wayne may have one, but they're not required core. The core of CS, let's say if you have a degree already, for example, if someone has a bachelor's degree already that's not in computer science or software engineering or data science or some related field, and they want to get a master's in computer science, there are prerequisites that you have to take. You don't have to have a bachelor's degree in computer science to get a master's degree in computer science. All three of my degrees are in computer science, so I did go the whole thing. But you do have to have a bachelor's degree. And if you have a bachelor's degree that does not have programming in it, then they say you need, okay, for example, you would need Calc 1, Calc 2, usually a course in statistics, a course in linear algebra or matrix algebra, usually a course in discrete mathematics, a course in organizational theory and architecture, and a data structures course, kind of like this one, or the one that I teach, 2353. The one that's at OCC is what I mean by this one. This course particularly, most colleges count as, if you're going for a master's degree, they usually count this as kind of a computer science 1, and some of them will accept it as computer science 1 and 2. So 2252 can sometimes go a long way depending on where you're going. Yeah, so that's basically what we've got for today. I don't have anything else for you. If you have any questions, though, please feel free to ask me. Are there any pertinent questions at the moment? Otherwise, I will stop the recording and then still stick around. But you're dismissed if you want to just call it a day. I'm going to stop the recording.